Hello, everybody. Welcome to the Speed to Lead 60-second sales secret show. Here we are obsessed with speed to lead because fortunes are won in 60 seconds. My name's Omar Jamal. I'm the CEO and host here at Atlas and of the 60-second sales secret show. Today we've got Jose Duarte with us, who's a leading professor of architecture at Penn State University and co-founder of X-Hab 3D, a leading 3D concrete printing technology company that he'll tell you all about. So with that said, Jose, welcome to the show.
Thank you very much. It's a pleasure to be here.
Excellent. So, Jose, why don't we get started and tell us a little bit about your business? We love 60-second pitches about your business and your story. You've accomplished a lot, so take it away and tell us a little bit about yourself.
Okay, sounds good. So several decades ago, I dreamt of making houses that were customized. And if I want to describe my career, I would say the first half of my career was devoted to find out how to customize the houses. So basically focusing on the design aspects, using AI to generate houses that were tailored to the user and to the site where were going to be printed. And the second half was devoted to find a way to make the houses. So once you find out how to customize the house, you need to find a way to make them, easy and fast. And that's why I got into 3D printing, maybe 15 years ago. And then 10 years ago, I moved to Penn State, and I immediately starting, finding connections. Penn State is very strong in 3D printing. It's a big area at the university. And I was lucky to find wonderful colleagues whom I teamed up with to continue developing the technology. So we founded the Additive Construction Lab, which is called ADCON Lab for short, and we participated in the NASA's 3D Printing Mars Habitat Challenge. And through our participation in that challenge, we were able to develop the technology, but at the same time, get the funding necessary to develop the lab, which we did. And then, a few years later, we had already, advised several students in different areas, focusing on different aspects of the technology. We teamed up with, Bruce Krzelski, who was leading the Extreme Habitats Institute based in Alaska. And we decided to co-found the company, which is X-Hab 3D. So basically, for me, the company represented an opportunity to transfer the technology that we were developing at Penn State to the market. So I teamed up with my colleague Sven Bilin, my other colleague Shadi Nazarian, and with Bruce, and also with a former student of ours who was also a co-founder at the company, and his name is Nate Watson. So the company basically has its core business, the idea of selling the technology to print houses. So our business is not to make houses. Our business is to sell the technology to make houses. So we basically help other companies adopt the technology. And at the same time, we continue developing the technology through a partnership with Penn State, because both Sven, I, and we are still affiliated with Penn State. So it works very well. So the lab, does the first steps in developing an aspect of the technology. When it's mature, then it's transferred to the X-Hab. And X-Hab is also developing its own, R&D. So the technology continues to evolve. And we have an agreement with Penn State that allows to transfer the technology, which is a very important piece of the process.
Yeah, wow. Wow. That might be the most unique story and coolest technology that we've had on the show over here. So, it's some sort of technology. Tell us a little bit more about the technology that home builders can utilize here, Jose. That's super interesting.
Yeah, so there are several companies working in the area of 3D printing for houses or for buildings at least. Ours is different because we have developed a mobile printing system. And the idea is that it's easy to deploy. You basically have two types of systems. You have a gantry system, which is like a large, 3D printer with, a gantry. And then you have the mobile systems that use a robotic arm. So we chose to invest in the robotic arm because of the flexibility. We were thinking about remote places, so we could take the printer anywhere in the world, or even to other planets as well, like Mars. And the idea was it needs to be easy to deploy, easy to transport, and easy to set up. And
Mhm.
that's basically the core idea about the technology that we have at X-Hab 3D.
That's fantastic. So if I understand correctly, when I see construction happening, there's those big trucks that are going down with that spinning wheel. That's the old school way of transferring concrete. You've obviously developed something super interesting here that people can print live on site, including space perhaps one day.
Right, and we also have the idea of using local materials. So the idea is that you don't have to transport materials, to a long distance or to a faraway place. The idea was, go to a place, find out what's available, and try to develop a concrete formulation that works based on those materials and use them to print. So we also batch on site, and then we print the house, basically. So that's the idea
Wow.
of.
Wow. So that's like sustainable material essentially. Like recycled material, you mean? Or what material exactly?
So it might be, byproducts of other industries like fly
Hmm.
ash or slag, or it might be sourced locally in the nature, like sand or other materials that we use to make the binder component of concrete. So concrete is a generic term to designate a class of materials that are binders. The Portland cement concrete is probably the most widespread concrete, but it is not very sustainable because it's responsible for tons of CO2 emissions. It consumes a
Hmm.
lot of energy. So we are trying to develop concrete formulations that are more sustainable, that don't use as much energy and do not have great emissions to the atmosphere. So that's an important component.
Absolutely, absolutely. So let's talk about the the facility itself. So when you actually go, like let's say I'm building a home, right? I'm one of your users. How does that experience look like for me? Because it's very different than the traditional concrete experience, which is, I'm sure everybody who's listening, seeing the big trucks that sort of come back. Tell us a little bit about, I guess, the user experience that are how
Right.
that would go live on
So
site.
as I mentioned before, the first step is to design a customized house. So we have a rule-based design system that basically has the rules to design houses of a certain category. And
Mhm.
then it interviews the user, and therefore it generates a 3D solution that matches the user's expectations, desires, and needs, but
Mhm.
also it's tailored to the site. So you basically use AI to generate a high performance, highly customized, and highly sustainable housing solution. So that's the first step. And then the second step is to use the 3D printer to make the house. So our plan is to print the whole thing, meaning the foundation, the walls, the slab, and the roof. We are not at that stage yet. So right now we are able to print the foundation and the walls, and are developing the technology to print horizontal slabs and roof structures as well. But that's the whole idea. So because we use a mobile robotic arm, the reach of the robotic arm is somewhat limited
Mhm.
because it's a piece of hardware that has a certain size.
Yeah.
And so what needs to be done is we need to decompose the shape of the house into segments that
Yep.
can be printed from within a specific location. So you print that segment, and when what's done, you move to the side and then print another segment, and so on until you print the entire house. And we have, algorithms that will do that automatically, meaning moving the robot from one position to the other, optimizing the process.
That's awesome. That's awesome. Super neat story there, Jose. I think I've never come across that. When I was looking at your website, I was trying to envision it, but it's great to hear all the work that you guys have done in that. So I guess like a couple of things that your clients and the early users that you might have sort of tested this about, what do they say when they see this and they work with you guys?
Right. So, as I said, the core business is selling the technology, but we also do demonstration projects to show, the potential of the technology. So
Hmm.
we have sold several machines so far for different types of users. including the military. It has also, a military application, but also for houses. So we also sold a printer to Alaska, and we have, sold other printers as well. And this summer we are planning to print 3 houses to demonstrate the potential of the technology. So we will print a house next to State College, where the headquarters of the company are located. And then this is going to happen in late June, early July. And then in August, we'll print another house in Alaska, in Nome, Alaska. And then in September, we come back to Pennsylvania to print the third house for Habitat for Humanity. So the first 2 houses were designed by us, and basically there are different variations of this, generated with the same rule set for different
Mhm.
clients and for different sites, one in PA, another one in Alaska, with very different environmental requirements. So Alaska gets very cold in the winter, as you know, and actually we only have a window of opportunity to print the house, which is in the summer. If we
Yeah.
miss that, then we need to wait for another year to be able to print the house.
Yeah. So why Alaska?
Well, as I said, Bruce had connections in Alaska, and we also thought, if we succeed in doing this in Alaska, which is such a demanding environment, we will succeed anywhere. And
Anywhere.
Bruce is the CEO of the company, so he's in charge of, fundraising, and steering the company basically.
Got it. Got it. And I guess with regards to the company itself, like if t tell us, I guess, a little bit about when you guys sort of landed maybe a dream client or an early client. What did they sort of think of it once the house was built? What sort of made the deal itself click for them?
So, as I mentioned before, my initial idea was to build affordable housing. So I developed this technology together with my colleagues, having in mind the making of affordable housing, because you know um, the world population is growing at a very fast pace, and it's impossible to supply enough housing to meet the demand. So you need to develop technology like this to be able to build houses that are customized, but in a very short period of time. So you're basically changing the paradigm. We're not talking about mass production anymore. When you use a model and then repeat the model, thousands and thousands of times. So we want to make each house unique, and that's very attractive to the client. Your ability to generate a house that has the best performance, for instance, in terms of energy consumption. So we want to minimize energy consumption, or other aspects as well, structural performance, and at the same time, look beautiful, which is also essential at the end of the day.
Yeah, yeah. I almost wonder if you could solve homelessness with this problem as well. I know that's a little bit of a mass home building process, but have you guys thought about that at all?
Yes, let's say you're an architect and you need to design a huge housing development with hundreds or even thousands of houses. So instead of designing one model and repeat that model over and over, or maybe 2 or 3 models, so basically you devise a set of rules, and then use a set of rules to design the houses. So basically, it's a two-step process. You first design the design system, and then you use the design system to generate customized houses. So basically, we are shifting the way in which the architect works, not designing a building, but designing a system that can be used to design buildings.
Yeah, yeah. Very neat, very neat. So Jose, if you could wave a magic wand and fix one thing in your business building process, what would it be? You're in a very unique position where you've sort of been in as a professor at Penn State University, and then now you've sort of built this lab, and then now there's business. And from a practical perspective, if you could fix one thing in your business, what would it be?
Fixing one thing in the business. I don't think it's possible, because the goal is to customize. So you're dealing with a moving target. Things are, we have moving parts all the time everywhere. So it's not possible to fix anything, and that's the beauty of it. So
Hmm.
you basically have a system that allows you to address a changing environment, changing in terms of, let's say, environmental aspects, or in terms of the business environment, the clients, and so on. So I don't think it could fix anything.
Yeah, no, that's fair enough. That's fair enough. So I suppose in that case, tell us a little bit about your, like, how does a customer find out about you guys, right? Walk us a little bit through your discovery process from the, like, if I'm a home builder as an example, how do I even find out about you guys? How do you guys contact them?
So you basically we have a website. The website has our contacts, and say you were interested in starting to print houses. So you don't want to use traditional system anymore, or you don't want to explore with a different system. So you contact us, and we'll sit with you, and we will try to find out what's the best way to proceed, given the profile and the business model of your company. So we can sell the equipment, but we also provide, services like we study with you what's the best way to introduce the technology. How can you design houses for a technology that's different than the traditional? So what I'm trying to say, we have hardware, we have software, but we also provide services, a business
Mm,
service, helping the companies adopt, 3D printing technology for housing.
gotcha. And that services component, is it primarily like consulting based? Is that kind of the idea behind it?
Yes. So let's say you want to explore the possibility of buying a printer. You contact us, we sit down with you, and we come to the conclusion, yes, it makes sense for you to buy a printer, but then you need to train your employees out, on how to use the system. So we provide training. So we are
Mm,
not just selling the machine, we are also providing training, and it will assist you. So we have a package that will allow you to, continue providing support, in the future. And then we also sit down with the architectural firm, or the builder that you work with, and try to explain how to design for this technology, because everything changes. You don't have just to design the shape of the building, you have to think about the tool paths. The architectural details change, and that's a very important aspect. So we will guide you through the whole process, covering different aspects, not just selling the printer, but providing services to make sure that you succeed, because that's a very important aspect. If you sell a printer and then people come to the conclusion they don't know how to use it, or it does not seem useful, then we fail. And that's not
yeah.
what we want. So we want to make sure that the companies who adopt the technology will succeed in their business.
Absolutely, absolutely. I mean, no, I must say this is one of the most interesting projects that I sort of come across. I guess my only question is, why do more people not know about you guys, right? Like, how do you spread the mass word of mouth, and what are you doing so that more people learn about you guys?
Right. So, I mean, we started the company 3 years ago. I've been researching this for over 30 years, and I'm not exaggerating. I
Hmm.
mean, I completed my PhD at MIT about 25 years ago. I was already working on this for my master's thesis. I actually started my bachelor's with, all this idea. So 3 years ago, I found the conditions with my colleagues to develop this. And I should say, this is not a one-person business. This is a team, a very
Hmm.
diverse team of people with different background, with different expertise, and that we work together to develop the technology. So 3 years ago, we founded the company. And obviously, it takes time. You need to raise the funding, make sure that you develop a product that's already mature enough to, go to the market. So we want to be cautious and proceed slowly but steadily, and that's why, maybe some people have not heard about us yet. Hopefully, that will change in the future.
Yeah, absolutely. How did you get involved in this 30 years ago? Like, you've been researching it, but what sort of sparked that interest? Like, maybe like what was the early day journey for this idea to even come to fruition?
Right. So I'm originally from Portugal, and Portugal at that time had some development problems. So there were people who were living in what you'd call shanty towns, and that was a sharp contrast between those informal settlements and the nicey, nitty, beautiful buildings that you find in the city centers. So I started thinking about how can we, make sure that everybody has a decent home, that everybody can benefit from the work of, an architect and an engineer, and that's, what triggered my mind. Luckily, I had wonderful people in college, wonderful professors, I went to MIT, found another set of people, so I keep feeding my imagination, and I was able to gather, to get the knowledge that you need to develop something like this. So basically, looking at the world, understanding there's a problem that needs to be solved, and turning that into your career. Basically, population is growing very fast. People need houses. We don't have a process to build fast enough, affordable
Hmm.
houses. So, that's the goal of, the people who are engineers or architects who have the technology. So that's the goal of the universities, to support the development of the society. And I
Yeah.
guess, I don't want to make this a very pink, nicey, rosy, story, but, I think you need to be, let's say, attentive. You need to look what's surrounding you and understand what are the problems, how can you contribute to solve the problem.
Yeah, yeah. No, absolutely. I think you're spot on. It's quite interesting what you're doing. We're all about like speed, and more in an environment of sales and how to contact your leads a little bit faster. But I think that's what you're trying to do in the home building sector. So with that said, tell us a little bit about that, right? What is the speed of building a home using this technology, and using this sort of concrete printing technology?
Right. So the construction sector is very conservative. It's very slow in adopting
Super slow,
new,
super slow. This is why I'm so intrigued
super
in this
slow.
conversation.
Yeah, super slow. So I mean, and it makes sense. A house is a big asset. It costs a lot of money. It's a big
Mhm.
investment for people. So, and companies that don't want to take risks because the environment is already risky by
Mhm.
definition. So I think the best way to succeed in doing something like this is to proceed slowly. Help
Mhm.
people making the transition. You cannot have a revolution from one day to the other,
Mhm.
because people need to adapt. And I'm talking about, like for instance, architects, the construction details. They need to understand what are the affordances of this technology, how you design for such a technology. The builders need to understand that it changes some of the paradigms, the established paradigms. So
Yeah.
people need time, and I think you need just to be patient and to make sure that you can help them make the transition.
Yeah. But now, assuming that somebody makes that transition and they're actually ready to implement this technology, how long, like the house that you have planned in Alaska as an example, how long will it actually take to go from the ground to all the way like a functional home?
Um, I think you can make a house in 1 month, and
Wow.
maybe less than that. And the printed part, it can take. I mean, it depends on the size of the house. So the house that we're building this summer, there are three-bedroom houses. So basically, 1,200 square feet. Um, it can take maybe 2 weeks to print, to make the 3D printed parts, and then you need another 2 weeks to finish the house. So
Wow.
I think a month is a realistic estimation of how long it takes.
Gotcha. And then what happens from a cost perspective? Is it more expensive than traditional building? A little bit less expensive? How does the costing at a
So,
high level work?
so at this stage, they cost about the same, but that's because you are still paying the cost of developing the technology. In the future,
Mm,
a 3D printed house can cost maybe 30% less than a traditional house. And there are also
mm,
other advantages. For instance, the US is very much affected by tornadoes and hurricanes, fires, and so on. So a 3D printed house, a concrete 3D printed house, is much stronger and much more resilient
mm,
than a stick-built home. It's not easy,
mhm.
to take it down because concrete is heavy. It's also good in terms of fire resistance. So there are many advantages. It's not just the fact it's cheaper and faster to build a house. It's also the fact that it's stronger and it can resist tornadoes. It can resist other challenges and so on. So there are many advantages.
Very Yeah, no, very true, very true. And how has the relationship with Penn State been throughout this entire process? I imagine that's a huge advantage that you have, even with that lab that you were mentioning a little bit earlier on.
So we started this research at Penn State with a grant of $20,000. It's not much,
Mhm,
but it was enough to get us started. So I think Penn State,
mhm,
as an environment that promotes interdisciplinary collaboration, that promotes
mhm,
people from different fields, to work together to develop something that's impossible for one person alone to develop. So Penn State has that kind of environment, so has incentives in place for that to happen. And then, Penn State is also investing in creating, let's say, a chain, a way for people to turning technology into businesses. Basically, Penn State is a land grant university. So the goal of the university is to help society, to help the Commonwealth. And therefore, being able to transfer technology to the market is essential in that process. So Penn State has in place several incentives to support, the start of business, the making of startups, spin-offs,
Hmm.
and so on. So you need that kind of environment. Otherwise, it's going to be very difficult.
Yeah, absolutely. Absolutely. No, that's fantastic. Well, that's a great story, Jose, and I really appreciate you sharing that with our audience today. I think, like I said earlier, this is one of the most interesting pieces of technologies that I've come across, and I wish you guys nothing but the best to, get it to mass production. And I see that you have a big vision for it. I'm excited to see this revolution come into effect. So I really, really appreciate it. I would love for you to sort of tell the audience, where they can sort of check you guys out, where they can learn more about you, or how they can contact you guys.
So the best way to start is the website, which is xhab3d.com, and you'll find information about the technology and our products and services. And you also have our contacts, so feel free to email any of us, myself, Sven Bilin, Bruce Krzelski, Nate Watson, Shani Nazari, and our wonderful, collaborators. Some of them were our former students, and they all have an essential role for the success in the success of the company.
There you guys have it. So our job here at the 60-second Sales Secret Show is to get you guys the most most innovative and interesting technology leaders and those folks that are working on the coolest technology out there and how what they're building out there. So today's guest did exactly that with Jose, and next time we've got a few other founders pitching in 60 seconds and spilling their secrets to us. Don't miss it. We will see you guys at the 60-second Sales Secret Show and wrap it off here. That's the pod.